In our final lecture for Chapter 3, we're going to talk a little bit more specifically about how the string works with the CN object, and then we'll wrap it up with the math class and things, operators, functions that we have available to us from there. So working with the string object in a CN statement is not as straightforward as it is with numbers. Because some of the extra characters that get trailed onto a string during input, we can use the CN operator, with the extraction operators, and it passes over and ignores any leading white space characters and so forth. It doesn't ignore them. So like if I entered something, like a name, and I want to enter my first and last name, it it stops at the first name, and when it sees the next white space, okay, it thinks it's done. Now the white space gets stuck in the buffer, and we talked about that idea of the buffer back in the last chapter when we were talking about the end to L and the \n. And so that extra space gets caught in the buffer, and my last name then ends up sometimes where it doesn't belong. And so we need to overcome that idea of the white space. And so CN is not the operator to use when using strings. Anytime I'm going to input characters and spaces, we don't want to use a CN object. Instead, we're going to use a function called the getLine function. All right, now it is a function, and so the getLine function is used with parentheses accepting parameters. So we've used the idea of functions in our previous work. So here's an example of a standard program. I have string name, string city, please enter your name. And the problem here is if I enter Mrs. K, there is this white space here. And so what's going to happen is, and we'll see this in the lab, is Mrs. and K are going to end up being stored separately from each other because it sees this white space here as the delimiter, the truncation component. Okay, if we recall that I could enter several things at the same time in the computer when we did the whole fractional and character example back in a previous slide, we had the whole, we had the fractional, and we had the character, and they had this space here, but it was one single CN statement. And so it behaves the same way here, where this becomes the delimiter. So it's going to end up putting Mrs. in name and K in city. And so then I'm not going to be able to put in my city, of Hershey. So we use the get line to override this issue. Now I have an extra piece I'm going to add to this prescribed slide here, but here you can see the get line. And so the getLine function is part of the string class. And so what it's going to do is it's going to use the CN object. It takes two parameters. The CN object is always the first one, and then the variable in which I want to enter my information into. And so this will allow for Mrs. K to be stored into name without issue. And then it will allow me to store my city into the program. Now, sometimes if I'm going back and forth between numbers and letters for input, I still have issues with the buffer. So when we get to the lab, I will ask that you add the CN WS, and all it does, it takes any extraneous white space that might be stored in the buffer and puts it there. And then that way I have a clean storage of my name, clean storage of my city. I'll do the same thing here. And so as I am looking at multiple data types and everything, it cleans it all up for me. We don't use the get line with numbers that I want to compute with. I can then add a standard CN statement, asking for, let's say salary. Okay. And then I can use that, as far as, that input. I don't need anything special with that one. I only use that execution with the string so that we know that Kate Smith is going to live in Raleigh. And we'll run this example in class because otherwise we find out that Kate lives in Smith and we want her to live in Raleigh. So we do need to understand how to overcome some of these buffer issues, and that's part of the language. We don't have this in all languages. It just happens to be something that is characteristic of C++, but this is one way to eliminate that issue. There are some other things we can do with strings. There is a function in the class that allows me to get the length of the string. We were able to do that back in our previous experience in BASIC. We did len. We would have done len state. Okay, and that will return the number of characters in state. This does the same thing. This is what we call a dot operator, used in Visual Basic a little bit. It definitely is something that we would use moving forward, this dot operator. The parentheses indicate that this is a function. This one does not take any parameters. What it will do, though, it will take state, find its length, and store it into size. It returns an integer. I can store it in a double if I want to, but it does return an integer. So this returns an integer. Okay, I can do what we call concatenate, or to append one word with another word. So I could, let's say, greeting one was Joe, and name one was Sam, and then greeting two would then equal Joe, Sam, as an all-in-one. There's no space. Okay, so I can append words together. I can append it if I added, let's say I had greeting one plus a space and name one. So that would put a space in between here, Joe and Sam. So we could do that. We can also use the combined assignment. For addition, I cannot subtract, I cannot multiply, divide strings, but the plus sign is a binary operator, so it can be used for addition, but it can also be used for appending things together. So let's talk about some of the functions of the math class that we will be able to use. As I alluded to earlier in this chapter, we cannot use the caret key like we did to create exponential math in our math expressions. And so we have to call on the math library to get a function to do that for us. And so we need to add in the preprocessor section the C math class so that I can access the functions of the math class. And so most of these take doubles and output doubles. And so these are some of them. I'll have to share that bottom one. There is one at the bottom of the slide that isn't present, but the POW is used for exponential math. It accepts the base and the exponent in that order. So if I ask double x to equal, the POW of let's say 4 and 2, then x is going to equal 16.0. Okay, it is overloaded. There is an integer version, so it could also take an integer, okay, and return an integer. But that is how I would call on it as part of a math expression. This replaces anything else I would otherwise do. I certainly can do 4 times 4, x times x, and so forth, but as we get to bigger powers, that might not be user-friendly. Some of the other ones we'll use in this chapter are the operators, or some of the geometry operators. All of these except the radial value. So this applies all the way down through. It accepts the radial value. So if I wanted to return the degrees, which we will do later, okay, I need to convert. Let's say I ask the user for a degree angle and I want to find the sine of the degree angle. I need to convert it to radians. So to convert to radians, converting to radians is pi over 180 times the number of degrees. So we will use that formula. So you want to make sure that you have that in your notes. The one that you don't see at the bottom is ABS. It returns the absolute value as an integer. Okay, the absolute value as an integer to the to whatever, variable or within the math expression. The hypotenuse takes the two legs. Okay, takes the two legs and returns the hypotenuse of the two legs. And again, that's your c squared is equal to a squared plus b squared. And those can be found on page 125 of your textbook, where you can explore those a little bit further. So the last one we're going to take a look at is how to generate random numbers, and we are going to do this extensively throughout the rest of this year, and being able to generate random numbers is always an important thing to be able to do. It takes two libraries, okay, the standard library and the time library. We will use the rand function, and we need to use our idea of casting. It does return a random number, an integer value between 0 and the largest number it computes as time has passed based on the date of January 1, 1970. So I will use the modulo with this in order to truncate a piece off of this. Okay, and then the SRAN allows us to initialize a random number. And we will use this throughout our code. I'll give you the code on how to do that. We'll talk about how to generate random numbers and how I can get maybe a specific set from 0 to 9 or 1 to 10, or even, 1 to 100, because we will use that idea moving forward.